Hello, welcome. This is a voiceover because I forgot to turn on my mic input, but here we go. So I'm showing off what we're gonna make. We're gonna make an escalator today with splines in Unreal. That being said, we're not actually making this exact escalator. We're just making the system to make this work. And there's kind of a distinction I'm showing you here where one is with static meshes and the other is with instance meshes. Both look about the same, but instance meshes, they don't actually move you correctly. They just kind of bounce you up and down, where the static meshes will actually carry you up and down the escalator correctly. Okay, there is a use case of the instance meshes that we'll get to after. If you stick to the end here, we're going to make this in Unreal 4.26. It's a fairly old version of the engine, but I'm starting old, so that way if you want to migrate this blueprint over to newer projects, you absolutely can, because it's easier to migrate forward than migrate back. Unreal often doesn't actually let you migrate assets to older versions of projects. And it's a simple enough system that we don't need any of the new features. Right now I'm just setting up the project, naming it. I'm just naming it Escalator Tutorial. I don't need the starter content. We're going to do it in the third person template. You can do this in the first person template as well, but the third person template is going to help us out here. So that way we can actually see the physics interactions with the escalator. I'm kind of setting up my project. There's a few things I normally do when opening these templates. I like to set everything to movable lighting and kind of clean out the hierarchy a bit here, the world outliner. Setting up they have the default spawn with a reverse scale for some reason, and on these I think it was just an error that just carried over into the templates. Now I'm just making myself a folder. When I'm just messing around in Unreal or trying to learn something simple, I typically make myself just a folder called custom art, and I just dump everything in there. It's not really a piece of art that we're going to make. Well, it kind of is, but we're just going to name a blueprint here. It's going to be called, it's just an actor. It's just BP underscore escalator. So let's open it up. The first thing we need is a spline. And that's actually the only thing we actually need in the component. I'm going to add a cube here, but we don't actually need a cube since we're going to add it we're going to spawn in a cube with the blueprint itself. That way we have a little more control over it and we can move it as we need. So I'm going to set the spline a little bit, and then we're going to start on the construction script. I'm going to just list out all the variables. Often you can make these as you're working on your project, but I'm just going to do them all now so you kind of get a sense of how complex this is and the different elements of this blueprint that we're going to need to create. So as a feature I showed at the start, this will have the option to reverse. So we're just setting that as a Boolean. And then the interpret speed is going to be how fast the actual escalator moves. And we're checking the little eyeball there, which is going to make it instance editable. Those are the same button on both the instance and down by the variable and in the actual details panel. The step offset is how big the far apart you want the steps. So you can kind of get a sense of how big the steps are if you go to the actual mesh and see, or you can make them really close together to make the stairs really close. We're going to then add a array And then this is going to be to hold all the steps in it, because we're going to want it in an array so that way we can move them. And then the last variable here is going to be the distance along a spline, which is not something we edit when we're creating it, but it's going to be a variable this blueprint's going to use in order to move all the steps where they needed to go. I'm starting off here by just clearing out the step array. This may not actually be necessary to clear out the step array, but I do it I have had problems where arrays would like build up a bunch of garbage data in them, so might as well just clear it out to start. Don't have to worry about it and just go from there. Now what I'm setting up is, I'm actually trying to remember, oh right, the spawning and all the steps. So I think a variable of about 60 is what worked well here. So that's why I'm setting up. And we're just dividing this by the actual spline length. The point of this is we want to know the number of steps we need in the spline. Then we're going to floor this, basically rounding it down, so that way we can do in each loop. For loop. We're actually going to reset this to the last index. And now we have the ability to do something for each of the steps at a different spot. Well, not quite at a different spot, but we have something that will do something the number of times in terms of the number of steps that we're going to need. So now we kind of know how many steps we need, and we need to space them out along the spline. So we're going to take the step offset and we're going to multiply it by the index of the for loop. And this will let us know how far along the spline we should put each of the things, which is what we're using here, the get location along spline. I'm also getting a rotation along spline, but as you'll see in a minute, you don't actually need this for an escalator specifically, because all the steps are going to be at the same rotation. They're going to be straight up and down, and then they just kind of move along the spline. You'll see what happens though when we do set up the rotation as well. We're basically just make a ramp, which is not actually what we want. We want steps. So now we're adding a static mesh component. You notice we don't actually have a static mesh component in the components panel because we're adding it here in the blueprint. We just want a cube. We can keep most of the other settings default. It's going to be a blank, or the collision is going to be the same. It's going to block everything. I use the chamfered cube right there instead of the normal cube. I think it looks a little better. If you really want performance, use the normal cube. It has less vertices, but it's not a big difference. Okay, so now we've made the static mesh, we've added it to the array, and this should work now. So I think I'm gonna pull it into my map. By the way, I have the key checker just because I like learning shortcuts that people use, but if those get in the way, I might turn them off. Okay, here we go. And as you see, it's just a ramp. And the way to fix that is just get rid of the rotation, which is what we're going to do here. So if we remove that, and we can just even delete that outright. We don't need it for this. And if you go, it's a ramp right there. And if when we compile, there we go, steps, which is what we want. Okay. So we've generated the steps. We put them into an array. We've position them along the spline in a incremental way so they're all spaced out correctly. Now we need to move them. So we're going to do this on tick, but we don't actually want just to move them a certain amount each tick, because that's going to be frame rate dependent. Because if your game ticks faster, it's going to move faster, or if your game lags, your stairs will move slower, your escalator will move slower, which we don't actually want. So what we're going to do is set up kind of an interpretation system. What I'm doing here is I'm just checking to see if the array is valid. Sometimes, I don't think it would actually do it here, but sometimes Unreal will, the first few frames before the construction script is finished, it'll try to run on tick. And if the array isn't filled, we don't want it to run yet. We only want this to function once the array is filled out and all the cubes have spawned in. So that's all that is. It's just a check to make sure it's valid. What I'm setting up here is the reverse function. It's a little tricky to explain in isolation, but basically, if it's reversing, we want it to interpret from the spline length to 0, but normally we want it to go from 0 to the spline length. So here's the f interp mode. We're going to set up delta seconds, and then the interpretation speed. I'm kind of looking at I have another project open as an example to kind of draw from. An interpretation speed of 120 is pretty good. You can set it to whatever you want. If you want your escalator to move faster or slower, go for it. We're actually going to kind of set this up in the scene to test it out. So if you notice, you can actually move the spline around per instance. So you can kind of drag it. I'm going to drag it to move up here, just so it actually takes us someplace. There we go. We're going to have a little bit below the floor, just so, like a real escalator, the steps kind of come out of the ground. Okay. And right now we just have a staircase that gets spawned on base of spline. We're not making a staircase though, we're making an escalator. So let's get these steps to move. So the distance along spline is the thing that's going to be slowly kind of increased. However, this number itself doesn't make the spline move. We need to find a way to use that number that slowly increases to calculate the position of each step we want it to be. Fortunately, we have an array with all the steps in it, so we should be able to run an each loop, or for loop, I think is what it's called. We'll see here. Let's see, what am I doing? I think I'm looking at my reference. Okay. So here we go, for each loop. We're going to set that up. This math is, I'm going to explain it as we do it, but it's going to be easier to explain once it's kind of presented here. We're going to set the location of each one of the array elements. So in this case, each array element is a step. Okay. So we have each array element. We're going to set it in the world location, and then we're going to, if you notice, in the same way like when we spawned in the array elements, each step is offset by the step offset. and then we're going to progress it in addition to the distance along the spline. And we're going to add that to the location of each step location. Okay, probably going to speed that up. But what we're doing here is we're getting the location along the spline, or we're setting the location along the spline. And what we're doing is we're taking the step offset, adding it to the distance along the spline. But the problem with this is that means for a lot of the elements, they're going to be beyond the actual distance of the spline. You're going to get a location that's farther along on the spline than the spline itself. So what we're going to need to do is we're going to get that location, and then we're going to subtract the spline length from it if it's greater than the spline length, and that will get us the location back on the spline, because we want the steps to cycle back through as the distance gets longer. So that's what this is checking for, is, hey, if the distance we get is longer than the spline length itself, then let's subtract it from the spline length and use that instead. So that's what we're doing there. Yeah. So currently how it's set up, it works, but it only moves in one cycle. As soon as the distance along spline equals 1, it stops. Or not 1, as soon as it equals the distance along the spline. So we need a way to reset the distance along spline. Fortunately, there's a complete command. We don't even want to set it here, but we can check to see if we should reset it here. And the check is going to be fairly simple. We're going to add in a little bit of additional logic for so it works when reversed as well. Because when it's reversed, we don't want to reset it back to 0. We want to reset it back to the distance along the spline. Okay. I'm using nearly equals here because sometimes the F interprets. I think they have some, like, with floats. This might not be an issue in Unreal 5 as much because they use double precision floats, but without that, I just use a nearly equals, so that way it actually fires correctly, and the precision of the floats doesn't stop the branch from triggering. And then we're just going to reset it to 0. So you notice you simulate, and to kind of check it's working, we're going to follow one step. Starts at the bottom, goes all the way to the top, and it resets. So that's working correctly. Excellent. You notice it's kind of popping out at the top. The way to fix that, we're just going to modify the spline a little bit. The one I made actually has a full loop, but if it's underground, you don't actually need to do that. I also added in like panels on the sides and stuff to kind of make the escalator a little bit nicer. You could obviously see how you could do that with your own style here. I'm just figuring out how to make the actual step system work. Okay, we're just going to modify these just slightly. And there you go. goes into the ground like an actual escalator. Very nice. You notice there is a weird kind of gap that right there that pops up. That's just because the step offset is not actually correctly divisible for the spline length. So if you wanted that to go away, you would want the step offset to be perfectly divisible with the spline length, which is totally possible, but you just, I kind of don't mind it because actual escalators have those. They have the little scene points. If you sit next to an escalator, you can actually see there's like one step that's kind of weird that comes through. At least maybe they don't have that anymore, but the escalators I remember near my house growing up. Okay. And then we're going to add a little bit of additional logic for reverse, because when it's reverse, we don't actually want to reset it to 0. We want to reset it to the spline length. And we can just use the select flow here with the reverse function, just like that. Okay, I think this is the system. So we're going to duplicate this so that way we have a reversed one. We'll modify some of the variables just so it's different. Maybe make it a little bit faster. Change the step offset. You can change these to whatever you want. Let's change this one as well, just to experiment, make it a little more fine. And there you go. You see the one on the right's going a lot faster, one on the left's going slower, but steps are closer. And there you go, a working escalator. As a little treat, I mentioned kind of an use case for, I'm just going to go through my blueprint here. This is something I like it when people do, because in case you followed along and yours is buggy, you can kind of look at like, okay, what's it supposed to look like? What are the variables supposed to be set to? That way you can check to see if you made any small little mistakes. As I was saying though, the other way you can use GPU instance meshes is when the physics doesn't matter. So the use case I'm going to pull up here is like an LMG. Let's see how laggy this is. So you see the wasn't actually laggy, but the recording's laggy here. But these aren't my models, by the way. These are models I just found online. But you can see this is just a miniature escalator. It's running a little bit of logic. This is obviously set up to activate once every round that gets fired. It moves one cycle, but it gives a really nice effect of a belt-fed machine gun of the ammunition going into the belt. So that's all I got for today. Hope you enjoyed that. I'll try to make these more regular. I have a lot of things I could do. See ya.